Okay, we are going to do some work with piecewise, but I don't know if you've noticed there are no notes pages in the packet. What I would like to do is sum all the problems from the next assignment with you that are in your packet. So on page 48, 49, and 50, the first homework problem that I would like to do with you is on page 49. And let's take a look at number 5. This is a great problem. I'm going to walk you through all the things you should be able to do, how to do it, and some of your homework will already be done for tomorrow. So the first homework problem on page 49 is number 5. And so we're going to graph 3 pieces. Let's get those pencils and those cool erasers ready. The first line we're going to graph here is 3x minus 26. Remember how I said it would be a great idea to plug these numbers in to find the endpoints of that piece. So the first value we're going to plug in here is 6. 3 times 6 is 18. And 18 minus 26 is negative 8. So we have the point 6 comma negative 8. The second piece here, the parabola, has 2 endpoints. So let's plug in 2. 2 minus 3, negative 1 squared is a positive 1. Negative 1 plus 3 is 2. And let's plug in a 6. The other endpoint is going to be 6, negative 6. And the third piece, if we plug in 1, negative 2 times 1, negative 2 plus 3 gives us a 1. Okay, it's nice to know those endpoints so we can capture the correct piece for the piecewise. All right, the first line right here is 3x minus 26. And some people freak out when the b value, the y-intercept, is way off the graph paper. Okay, I know it's going to be way off the graph paper, and I know it's going to be an uphill line because of the slope. So maybe what I'll do with this one is start at 6 comma negative 8. 6 comma 5, 6, 7, 8. Negative 8 is right here. And I'm going to use the slope, rise up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. So if I kept going down, I agree, the y-intercept would be way, way, way off the graph paper. But I don't need that piece anyway, because I need numbers more than or equal to 6. So I'm going to be needing 6 and on to the right anyway. So if I plug in 6, that's going to be a closed point right there. So maybe you're even getting as good as this too, and you're only plugging in or only graphing the piece that you need and not even having to erase the other half. Okay, the middle one is going to be a parabola. Okay, and parabolas are a little trickier because you got to get the curve the right way. I'm going to go 3 to the right, 3 up, 3 to the right, 3 up, and that's the vertex. Now, I know there's some endpoints, but I really want to get the shape first. It's opening down, but no stretch or shrink, so it's going to be the regular growth pattern. Over 1, down 1, over 1, down 3. This is great practice for your test. Over 1, down 5, keeping it fresh for the test. So let me just do a light pencil here of the parabola. And now I'm going to take a look at those endpoints. I only want the parabola between 2 and 6. So at 2, the parabola is at 2. Is that right? 2 comma 2? Yes. And take a look at these inequality signs. Open or closed bubbles? Open bubbles. Open bubble at 2. 3, 4, 5, 6. I think the parabola is going to go all the way down to there. 6, negative 6. Oh, good, that's working. Another open bubble. So I want the parabola from 2 all the way to 6. Let's just highlight those points. And let's make sure that you erase everything inside of those open bubbles so they look a little more open. And all of the parabola that's less than 2 or more than 6, you only want the piece between 2 and 6. Is this one a function with an open and a closed? Yep, definitely a function. It's only intersecting once. The last one is a line up 3. 1, 2, 3. The slope is down 2 over 1, down 2 over 1, down 2 over 1. I only want the line less than 1. I better go more to the left. I better go up to left 1, up to left 1, up to left 1. Come on, there's more graph paper there. So if we start at 1, the line is at 1, 1. That's exactly what I was expecting. I'm going to put up a closed point there, and I want x's less than 1. So I want all of the line going less. The line at 0, -1, -2, -3. I don't want any of the line that was going this way. Okay, and let's just do a little paper test to make sure that we don't have two pieces in one section. So first I have red graph. That's good. Then, oh, look at that, then there's no graph. That's weird. Then there's green, 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 green. Oh, when green stops, it looks like blue takes over. Perfect. We only should have one color per section. Domain is the set of x values. What's the smallest x value? -infinity. Okay, and the graph keeps going all the way until +1. Then there's no graph at 1.5. So +1 is going to get a bracket, and then we're going to pick up again at 2. But since that's open, let's use parentheses. 2. The graph keeps going. Now what about 6? Is there graph at 6? Yes, so keep going all the way to infinity. Smallest y value? Smallest y value is -8. It's a closed point, so let's put a bracket. And let's see, don't worry, as you go up the paper, as long as it's being used somewhere, let's keep going. Yes. Oh, 3 places. Yes, 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 all the way up until infinity. Okay, drawing some piecewise. I'd also like to go and work you through number 6. Let's go do this piecewise. Another graph that has 3 separate pieces. An absolute value graph, square root graph, and another square root graph. Wait a minute, there's no x there. That's just a really fancy number. That's a y equals number. That's a hoy! Okay, so we've got 3 pieces. Let's go ahead and plug in our values. If we plug in 2, 2 minus 2 is 0. Hey, who knows what the absolute value of 0 is? The answer is 0. Let's go graph our middle piece. There's 2 values here I'd like to plug in. I'm going to plug in 2. And square root of 2 minus 2. What's the square root of a 0? Also a 0. Let's also plug in 7. 7 minus 2 is 5. Radical 5. Oh, that's interesting. Radical 5. Okay. And this one is also really interesting because when you plug in a 7, there's really no x value to plug it in. The y is always radical 5. All right. Let's graph our absolute value here. No stretching, no reflecting, but it does shift 2 to the right. And the regular growth pattern for absolute value is over 1, up 1, over 1, up 1, over 1, up 1. So it's going to have points going off the graph paper like that. And up 1, over 1, up 1, over 1, up 1, over 1. It's going to be going like that. But maybe what I'll do here is look a little bit because I only want the graph less than or equal to 2. So if I look at the value 2, it's right here. And since it's equal, I'm going to put a closed point there. And I want the graph less, like 1, 0, -1. So this is all of the absolute value graph that we definitely want, this piece right here. And we're going to erase this side. It actually kind of looks like a line. But that's what an absolute value graph is, 2 lines. Okay, the square root function shifts 2 to the right. I guess it's going to start right there. No stretching. Regular growth pattern. Up 1 over 1. Up 1 over 3. Up 1 over 1, 2, 3, 4, 5. Okay, so here's the square root function like this. Let's go get our marker or our pen now. When I plug in 2, I get 0. It's exactly right. And since they're equal, I'm going to put closed points there. And at 7, oh, 7 is weird. 7 is like 2 point something. Radical 5 is 2 point something. That point is right there. And that's going to be a closed point. So the absolute value graph is going to go to right there and stop. And I don't want the rest of this. So the only really nice points was this point. 1, 2, 3, this point. That was not a nice point. You see how it's in the middle of a box? That's how it works. And this last one right here is ahoy. Y equals radical 5 again. Isn't that 2 point something? And it starts at 7. Starts at 7. Radical 5, that's right where that other point was. It's the same point. What happens if I have a graph with a closed point and then it meets up with a graph with an open point? What's an open plus a closed make? Closed. The closed one fills in the open one. But this is a hoy, so this is going to be a horizontal line starting right there. And it just goes straight off the graph paper like that. Look at that. Is this graph continuous? Absolutely. Totally continuous. The domain, the set of x values, from negative infinity all the way to positive. I feel like writing all reals. And the range, the smallest y, there's no negatives, the smallest y is 0 with brackets all the way to infinity. Okay. I am going to do one more of your homework problems, and that's going to be on page 50. So if you could please turn to page 50, we're going to go take a look at number 12 together here. Let's go take a look at number 12. So I see that there's a parabola, I see an absolute value graph, and I see a horizontal line. So we're going to need 3 pieces. I'm going to get my answer key here ready. 1, 2, 3, and 1, 2, 3. I like to do some work on the graph and then write the answers in the slots once I have things figured out. So this first one here is a parabola, so I know it's going to be y equals something squared. Now the vertex is down there, so 5 left, 10 down. No reflections, so it's going to be x plus 5 quantity squared minus 10. Is it the regular growth pattern? Over 1 up 1, over 1 up 3, over 1 up 5. Oh, no stretching. Regular parabola. It just had some shifting. Okay, for the second piece, this looks like an absolute value graph, but it looks like it got reflected over the x-axis. So I'm going to need a negative out in front. It got shifted 2 to the right, so that's x minus 2. And the vertex is also up 3, so plus 3. The growth pattern looks regular, over 1, down 1, over 1, down 1, so I don't need to put any number inside or outside for any sort of stretching. And the last value here, this is a hoy, this is y equals negative 1. Okay, when you go to do your equations, you don't need the y or the equal sign. We just need the equations. The first one is quantity x plus 5 squared minus 10. The second equation was negative absolute value of x minus 2, close of absolute value, plus a 3. And the third equation was just a horizontal line at negative 1. We already have the y and the equal sign. Now we have to say the values. Here, the parabola starts at negative 2 and goes left, left, left. So I'm going to say if x's are less than negative 2. For the middle one, the absolute value graph, it goes from negative 2 all the way up to 6. And those are both open bubbles. So I'm going to say negative 2 less than x less than 6. For people that like to do interval notation, yours would be looking like this. From parentheses negative 2 to 6. This one would have been negative infinity up to negative 2 parentheses. Okay, either notation's fine. I'll take either one. And the last one starts at 6 and goes to the right. So x's that are greater than 6, or you could say parentheses 6 to infinity. The domain for this one, let's take a look at the set of x values from negative infinity. Negative 2 is not being used anywhere, so we're going to stop, say negative 2, union, parentheses negative 2, all the way to 6, stop, it's not being used anywhere, union, 6 to infinity. And the range, the smallest y value is negative 10 with a bracket. Up, 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 is there a value at negative 1 being used? Oh yes, lots of places. In fact, this one was up, 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 so it would be all the way until infinity. Remember, whenever you have any sort of stretching or shrinking inside, you would have to use parentheses. I know that neither of these did, but if they did, you would want to put parentheses, and then the number would go like right there. And remember, horizontal is weird, so if it had a stretch of 2, you'd put 1/2. All right, bring these packets tomorrow, and we're going to finish them up in class. Good job.